with all these questions that we have done so far, one thing is clear, that we have to understand accurately where to use what operation. Where should we use a intermediate operation like a map or a filter? Where should we use a terminal operation? Hello and welcome you all to my YouTube channel. Java Streams is considered to be one of the most important and one of the historic API improvements that came in as part of Java 8, and it helped in adding functional programming concepts. It also helped in making our code from 10 lines of code to maybe 2 to 3 lines of code, making for more concise code, more easily understandable, easily readable code. But at the same time, it also happened to me earlier that most of the code which is written using streams, a bit of complex logic which is simplified using streams, is not very easily understood because of the variety of operation that goes under the hood. And if you don't understand the basics of those operations, like where does a map function is used, where does a filter is used, where do we use a reduce, so it becomes very difficult to write any complex logic using it. Forget about simplifying the logic. So that is why this video is going to be more code focused, more hands-on. So we'll do 10 coding questions from scratch. We are going to learn about streams, the different operations using streams, and how can we solve day-to-day problems using streams. We'll try to build a foundation by solving those 10 coding questions, that in future, if you have to solve any problem on streams, the foundation that we are going to build today with these 10 coding questions is going to help you a lot. So the code for this is already documented in the GitHub repository. You'll find it in the description. Whatever the bare minimum theoretical knowledge you need about streams is also documented as part of this README. So you can go through that. I'll also give a brief context for absolute beginners. So you don't have to worry about the code and the theory. Everything is documented. All you need to do is pay your 100% attention and try to understand what we are doing, why we are using a certain operation, how we are doing it, and then later on use the GitHub repository to find the solutions. I'll also try to add some more coding questions to this GitHub repository as well, so that you can practice more on Java streams. So today's video, as I said, is going to be hands-on. So we'll do the 10 questions live coding. So pay your attention, try to understand what we are doing. So by the end of this video, I am hoping that for absolute beginners on streams, you'll be very much confident in answering or solving problems involving Java streams, and which also involves a bit of Lambda expressions. So yeah, so without further ado, let's begin. So just a brief overview about Java streams for those of you who are not aware of what Java streams are. Although I've documented all the theoretical things over here and I'm going to link it in the description. So we'll talk about what streams are, a brief about why streams came into existence, why should you learn about streams, and then we'll see how do we create streams and what are the important operations and the terminology associated with that. So this is more of like a very brief theoretical aspect. This video again is not about the theory or about what Java streams are and all the related terminology about Java streams, but this video is more focused on hands-on. But still, just to give a brief context of what streams are, they are nothing but a sequence of elements that come in from a source. Now a source can be anything, we will see that. What is the background about this? So like I said, verbose code, lot of if loop, lot of if conditions, a lot of looping construct and conditional logic. So in order to get rid of that, in Java 8, this new way of functional programming came into being, in which combining the power of Lambda expressions and streams, we are now able to write more readable, more concise code. And it is also not just about the fact that it is concise and more readable, it's much more expressive, and it is more maintainable also, because if you write something which is 10 lines of code, and if your peer is able to write the same logic in 3 lines of code, obviously the one which is being written in the 3 lines of code is going to be more preferred. Okay, so that is the thing. When we will deal with some of the coding questions, we will see that how the difference is. So here I have given the importance of learning streams. Now coming to the operations part, so here are the common ways how do we create a stream. So we are going to follow the first method, in which we are going to take a list mostly, and when we take a list, from the list what we do is we take the name of the reference of the list, numbers, and dot stream, and that returns us a stream of that particular integer, or this is called a boxed stream. Okay, so a stream of the whatever wrapper class you are putting, it can be a string, integer, long, float, double, whatever. So this is about when we use objects or when we use the wrapper classes. If you are given a primitive array of integer, in that case you have to use the arrays class and then arrays dot stream and pass in the name of the variable and then pass in the array name, and that is how you get the int stream. So there's a subtle difference between So there's a difference between int stream and stream of integer. This requires you to understand the concepts of boxing, unboxing, and auto boxing. How the primitive integer gets converted into integer object, and how the integer object gets converted into primitive object, and how everything happens automatically using auto boxing in Java. So all of that. So these are the two things. Apart from that, if we have a file and from the IO, if we want to create a stream. So like we said, it is a sequence of elements which comes in from a source. The source can be a list. The source can be a primitive, a fixed size array. The source can be a IO input. It can be from a file. And the fourth one is a generator. So you want to generate an infinite stream. So 42, 42, 42 like that, a infinite stream will be generated. Of course, we can put a limit over here, but this is like generating a stream of elements of our choice. So these are the ways in which we create stream. Now the most important part are these two operations, which we will talk about often when we write the code: intermediate operation and terminal operations. Streams have these two operations mandatorily, and you have to understand the differences, because only then you can understand where to use what. Intermediate operations are only used for some kind of a transformation, aggregation kind of a logic. For example, you want to find out the distinct or the unique element. So that is, what are you trying to do? You're given a list, you are trying to pick out the unique elements, or you're trying to do some filter to find out the even numbers or the odd numbers from a given list of integer. So these are nothing but transformation operations. We're transforming the given data set, and that is why they're called intermediate operation. Filter and map are the most commonly used operation. Then there is something called a terminal operation. Terminal, as the name suggests, this is done the very last operation, which is done towards the end to give us the final result. So for each is another, for each is one of the most common terminal operation that we use with Java streams, in which we lastly iterate over the given output that we have, and then we perform some action for every element or for each element in the stream. Apart from that, we have collect. So collect and for each are very commonly used. So that is all about the theoretical context on what Java streams are. So now let's move into the code demo. So starting with the first question, find the sum of all the elements in a list using streams. First, take a list of integers. If we were not using streams, how we would have done that? We need to loop through all the numbers. First, take a sum variable and keep on adding to the sum variable, and finally print out the stub. So that would take easily 2 to 3 lines. But now we are not going to do that in 2 to 3 lines. We are going to use streams. How do we use streams along with list? The name of the list dot stream. So now it is something like, instead of looping over it, we are now saying your source is this list, which is called nums. Stream from that list one by one, give me all the numbers, and I'm going to do some terminal, and I'm going to do some transformation on every number, and then finally do a sum of it and print out the result. So now we have done the stream. Now what we have to do? So when you again give a dot, there are a bunch of functions that we can do. Remember, in the beginning we told about two things: terminal operation and intermediate operation. So first, the intermediate operation has to happen, which is going to do some filtering, transformation, mapping, all of that on every number, and then finally it is going to do some terminal operation. In this case, it could be as simple as getting a count of the numbers and then printing it out. So now in this case, what we need to do is, first of all, we need to map it. Map to int, what it does is, in this case, we see that we have the wrapper object, that is the integer class. But if you have to do sum, the sum always happens on a primitive integer. So when we have to do map to int, so as we can see, map to int is nothing but an intermediate operation. So over here, we have the integer class. And now what we are going to do is we are going to convert this integer into primitive int. So we use int value. Why are we doing this? Because now when we are trying to do a sum, now we are able to do this. If we had not done this, and let's say we would have done something like this, it would have given an error. So mapping, in simple words, is a transformation. For every element, we are trying to convert every element to its equivalent, primitive equivalent, and then we are trying to do a sum of it. So now when we have done the sum, now what we are going to do is we need to store it somewhere. So we'll say int sum equal to this, and then we are going to print out the sum. It's that simple. So in single line, we have done all the required operation. The intermediate operation is map to int, and the terminal operation in this case is the sum function. No need of any for loop to traverse, no need of manually adding to this variable. So now let's try to print out the result. We got 50. So we got the correct answer. Moving to the next question, we have to find the maximum element using streams. So what we can do, we are going to utilize the same list only. I'm just going to comment out these operations. So now we have to find the maximum sum. Again, without using streams, how we would have done? Again, a for loop, again a check, a if condition to check, but we don't have to do all of that. What we will do, nums dot stream. Now again, when we are doing stream over here, what we need to do is we need to find the maximum element out of it. So if we just write max, we are able to get max. Now, is that all? If I just do a max, is it all? No, it requires a comparator. Because why it requires a comparator? Just to give a small context about what comparator does. Comparator is going to take, given a list, it is going to compare the values of every element, and then it is, see, the condition that we are writing, if given number is greater than max, then store the max equal to given number. This kind of the traditional logic we used to write. So that is nothing but the comparison logic which we are writing using the if condition. Now we don't have to do that. We are just going to say comparator dot natural order. So comparator dot natural order is a static method. What it does is it returns a comparator which compare the objects in the natural order. Natural order in this case is that they're going to compare it in ascending order. Okay, so they're just going to compare every element, and based on that they're going to do the max. So the internal logic which we were writing using the if condition is gone. We don't have to do that. After that, what we can do is, now in this case we are going to do a get. Why? Because this max returns an optional. So now because it's an optional, so we have to do a get operation to get the value, and now we are going to store it into our max. So now we can print this out. 5. If I change this value to, let's say, 32 and run it again, we get 32. So that is about the max operation. No need of manual comparison. This comparator interface is able to do the comparison for us. Moving to the next one. Next question is, we have to count the number of strings that start with a certain character. So this clearly specifies that there's a condition that we have to check if the string starts with a certain character or not. So now let's take a list of strings. Let's say we'll take fruits. So here we've taken a couple of fruits. So as we can see, there are 2 fruits that starts with B and 3 with C. So what we are going to do is we are going to do the same thing, fruits dot string. Now over here we need to do some intermediate operation. What is the intermediate operation in this case? In the earlier cases we had to do some kind of a operation, like we were trying to find out a max, or we were trying to do some kind of a mapping. But in this case what we need to do is we need to add some filtering logic. We need to filter it out. So we will call the filter method or the filter operation, which takes in a predicate. It's nothing but a condition. What is our condition in this case? We'll use a lambda function. That, see, this is a stream, which means it's a, like I said, the source is every element or every string in this, every fruit in this list of fruits. So given a string, so S denotes given a string, or I can say like given a fruit in my list of fruits, we need to check if fruit dot starts with. We have a method in string called starts with. We have to check if that starts with C, because we want to check, count the number of strings that start with a specific character. So there are 2 things. One is the condition that the string has to start with a specific character. Second thing is we need to also do a count. So 2 operations we are doing. We are doing filter and we also have to do count. So now we have done the filtering already. So that is one operation that we have done. Now what we have to do is we have to do some terminal operation. So what is the terminal operation in this case? We want to count it. So we have to say count. Now we have to store this. How many fruits have started with particular character? Now this gives an error because count is returning a long, so we have to cast it to long. Now we can print this. We should ideally be getting 3. Okay, if I change this to B, then we should get 2 fruits. Okay, moving to the next one. Over here, we need to convert a list of strings to uppercase. So let's say we'll take this above list only, and we have to convert to uppercase. So what we can do is, again, we have to do some kind of a transformation. What is a transformation? Converting to uppercase. So again, whenever we do some kind of a transformation per object or per element, we use map. Map has many different variations. Like we have seen earlier, map to int, which takes in another function within it, where you wanted to do integer.int value, as we can see over here. In this case, I also want to do map, but I don't want to do any kind of map to any integer stuff. I just want to do a generic map in which I am going to pass in my condition. So what is my condition? So in string, we have a bunch of methods. One of them already exists, which converts to uppercase or to lowercase. Okay, so here I will transform every string to uppercase, which is our list of fruits. After we do that, we are just going to do some terminal operation. We could have done a count also. We could have collected into a list, or we can, let's say, try to explore this option, which is called a for each. This is also terminal operation. For each is nothing but like a for each loop. Now, for each, what it will do, it will transform every fruit into its uppercase equivalent. And now I want to print it out. So I don't want to store this and then separately print out. I will just say system. I will use a method reference. So this is also a method reference, where the first is the name of the class, double colons, and then the name of the method of the class. So system class has a method called println. So what we are going to do, system.out and then println. So in one line we have printed also. So now let's run this. So we can see all the fruits are now printed in uppercase. Okay. Next question, we are given a list of integer and we need to filter out the even numbers and also count the number of elements that satisfy this condition of filtering out even numbers. Without streams, what we would have done originally, we would have used a for loop to first traverse to the list, then would have written the ifs condition to check if mod 2 is equal to 0, then it is even, if it is equal to 1, it is odd, all of that. Now what we are going to do is, we are going to do all of this in one single line. First we will try to filter it out. So we'll use the same integer list which we had the nums over here. We had to just change like this. Okay. So now we will do a stream, and we have seen before this filter operation before. Now in this, what we are going to do is, we are going to say that every num, and we are going to write a lambda expression that num mod 2. So now over here, what we are saying, if the condition, this condition is satisfied, then we have filtered out all the even numbers. Filter out means just extract all the even numbers from this list. And after that, we can of course do a count, or we can do a for each to print out. So let's say we'll do a count, and this count we can print out count of even. This returns a long. So we're just going to print this. So how many even numbers are there in our list? There are 2 and 4. There are 2 numbers only. So we should ideally get 2. And if I change the conditions to, let's say I want to print out or filter out only the odd numbers, I should get 3, 1, 3, and 5. Okay. Or if you don't want to do count, you can anytime do this for each loop and try to print out all the elements. Okay. So moving on to the next one. Now we are doing a different operation. Now we want to do an average for a list of floating point numbers. Same drill. We'll do a stream. Now notice here also we have to do, earlier we did a sum, right? Now we have to do average. So we cannot do directly average. So again we have to do some kind of a mapping. Here we are going to map to double, in which we are going to convert to a primitive double. So the same thing, we have a double class, and then we are going to do double dot double value. Okay, this is a method reference. Now we can use the average. We have mapped it, so we have done the average, and after this we can just try to do a get as double, because average returns an optional value. We'll do this, and we are going to capture the number over here, the output over here, and print it out. So with all these questions that we have done so far, one thing is clear, that we have to understand accurately where to use what operation. Where should we use a intermediate operation like a map or a filter? Where should we use a terminal operation? Okay, anyway, when you use IDs such as IntelliJ, you get the IntelliSense and the auto prompting of what goes with what. But the basic knowledge of this helps you when you're trying to write code without an ID. That is the reason practice is important, and that is the reason why practice with so many different types of question is also required. So we got 1.6, the mean or the average value of all the numbers. Moving to the next one. So continuing with the next question, we have to concatenate all the strings now. So let's say we'll continue to use our list of strings, that is fruits itself, and we want to output it by concatenating it with some delimiter. So earlier, if we had not used a stream, we use str, and then we use the plus operator to concatenate, or we can use some string builder and use the concat method. But now when we are going to use streams, let's see how can we do that. So I'll just comment out the previous code snippets. So again, same thing, we have to stream it. Now we are going to learn about a new method or a new operation, and that is called collect. So in collect, the most common operation, this is the terminal operation of course, is the most common is, after doing all the operation, we call this collect, and then we collect all the result into a list or into a set or into a collection, and we print it out. But there is an interesting method called collectors.joining. So if we take a look at this, it just concatenates the input elements into a string and it takes in a delimiter. So this is what we could have done traditionally using a string builder and then trying to append it. But this is what it is doing internally. So if we just call this collectors.joining, over here we have to give a delimiter. So let's say I want to concatenate all of them using comma. So I'll put the delimiter. So now we have done that. This is a terminal operation. We don't have anything else to do. Then we can just say these are the concatenated roots. And we can print this out. So let's run this. We see that all the list of string is now concatenated using comma. We can use any delimiter we want. Let's say I want to use double colons. So it should be returning me a list. It should return me a string where everything is using a delimiter of double colon, everything is concatenated. So this is how in single line using strings we can concatenate all the strings. Moving to the next question, now we want to remove duplicate elements from a list. So let's say I'll use the original array of numbers and let's say we'll add some duplicate elements into it and see how can we remove the duplicate elements. So what we have to do is we're going to use nums, comment out the earlier sysouts, stream it. Now we have to remove a duplicate element. Okay, so this is the operation that we need to do. We use a function called distinct. So this is again an intermediate operation. So we have seen map so far, we have seen filter. There is something called distinct. So we can use distinct, and as the name suggests, anything on which we call distinct, it anyway will remove it. So after we do that, we can simply run a for each and just try to print it out like we have seen earlier. That's it. Let's run this. So we get 1, 2, 3, 4, 5 itself, because earlier in the list I had added 2 and 3, and since 2 and 3 are the duplicates, they are removed. Okay, moving to the next one. Okay, so the next question is we need to sort the objects based on a given attribute using streams. So we are given a list of objects. This is a person object that we have created, a list of custom objects. And now we want to sort this list of person objects or persons into a given based on a certain attribute. So basically there are two attributes, name and age. So let's say I want to sort all these people into in ascending order of their age, or I can sort them based on the names in ascending in alphabetic order. So if we take a look at the person class, there are basically two ways to do this. If we want to implement an interface, this is something called a comparable interface, which will take in the type. And then this has a method called compare to, which we need to override and write our logic of comparison. If I want to compare it based on the age, I can just say compare the age of this, and it returns an integer value with the object that I am passing. So if the ages are equal, it is going to return 0, and the value of int will be 0. If it is greater, if current object is greater, it is going to be returning 1. Or if it is lesser, it is going to return -1. So you can read the documentation of compare to and the logic that it does by looking at the comparable interface. I don't want to go into the details of that, but two ways. Number one is you implement a comparable interface. You write your logic of comparison by age or by name, what you want. In case of name, you cannot write like this. You have to do this dot name dot compare to, and then you have to write o dot name, because it is a string, and this is how you have to do the comparison logic if you want to write it sorted based on alphabetical order. But in this, if we don't want to touch the person class, if we don't want the person class to implement any interface, then in that case we use another interface called comparator. Okay, for using comparator, I don't have to implement any interface in my base class. Okay, so let's see how can we do that. Over here, we'll first see the process of sorting this list of people without using streams. So we'll use something called class called collections, which has an inbuilt method called sort. Those of you who use primitive arrays might be familiar with arrays.sort, but arrays.sort takes in a primitive array. In this case, we have a list. So we will not use this. We pass in the name of the list people. It takes in another argument which expects a comparator. So what it does, comparator has, now this argument that we are passing, second argument, there are different ways of doing it. Over here, we're going to use a static method. Apart from that, you can write your own comparator and then use it, but we are going to use static methods. We are going to say comparator.comparing. Okay, in this, we are going to pass in a sort key. So what is my sort key? I want to say the person and then the method reference get age. So based on the age, return, do the comparison and then sort it. So I can just print it out to check if it does the same. So I have different people with different ages. I should be able to compare this in ascending order of their age. So let's see this. Now, this is what we are doing without streams. We'll also see how can we do it with streams. So we see that age 20, 21, 29, 30, and 56. They're arranged in ascending order. If I have to use streams, so this was first way of doing. If I don't use this method and want to use streams, second will be I'll use people dot stream. Like we use distinct, this is also another intermediate operation for sorted. So as we can see, this also expects a comparator. So I'll use the same comparator that we use, comparator dot comparing. Now I want to compare it on the basis of the name. I want to arrange it on the basis of the alphabetical order of the name, and I want to print each of them out, each person object out. So I'll just print like this. And let's run this. We get Alice, Anna, Barbie, Bob, and then Charlie. All of them are in alphabetical order, but the ages are not. So this is how we can use streams to sort the given objects based on a given attribute using comparator. And also I showed you another way of sorting the same without using streams. Moving to the last question for today. We need to check if all the elements in a list satisfy a given condition. So far we were given a certain condition and we had to write our code to align or to satisfy that condition. Now we have to check if the list satisfies that condition, if all the elements satisfy this condition. Okay, so let's take an example. So let's say I've taken a list of numbers where all the numbers are even. Okay, it can be anything, whether it can be as simple as, so all of them are even. Now I want to check if my given list of numbers, are all the elements satisfying my condition, like if are all the elements even or not. In the previous code snippet where we were just trying to filter out the even numbers, we were given a mix of numbers and we were filtering out. Over here it is not a filtering, we don't have to filter. What we have to say that we have to check, it is like a check condition. You have to check if all of them satisfy the condition. So for doing that using streams, what we do is there's something called a terminal, there's a intermediate operation called all match. All match, and then one more is any match. Any match is like if any of the elements match that certain condition. But over here we have to say if all the elements match or not. So we'll say all match, and then within this we are going to pass in the predicate. We have already seen what is the predicate of lambda expression we can use, and we can say that does this element abide by the condition of element mod 2 equal to 0. So this is my condition for checking if something is even. Is it even or not? If it is even, so this is what it's going to do, and of course it is going to return a Boolean value. Is, you can say, is even. So I want to check if all of them are even or not. So let's try to print out. What do we get? Just comment out the previous one. We got true. If I add an odd number over here, let's see what happens. I get false because now not all numbers are satisfying the condition of being even. But if I change this to any match, like if at least any one element matches an even, then it should return true. Then it returns true. So that is all for this session. We are going to wrap up with all the 10 questions like we had told in the beginning, where we learned a bunch of different intermediate and terminal operations using streams. We learned a bit about comparators and comparable also, like custom object sorting. So thank you so much for watching this video. The code for this is going to be available in the GitHub repository. I would encourage you guys to first try out the questions on your own after watching this video, and then match it with the solutions which will be available in the GitHub repository. Thank you so much for watching.